Hello students, good afternoon to one and all. As we already started with the model 3 nuclear power plant, so in that model only today we'll discuss it on a very few topics. So which are those topics? Let me start this contains. So the first one, it is a nuclear reaction, nuclear fission process, nuclear chain reaction, nuclear energy, nuclear fuels. So these are the 5 bits we are going to discuss in today's session only. Okay, let me start with the nuclear reaction process. The first one, what it is there, nuclear reaction process. So nuclear reaction means here the heavy element it is nothing but what, that is the uranium 23592 here. So that is nothing but the target nucleus. The target nucleus, it is nothing but the heavy element, that is uranium 23592. It is going to be interacted between the projectile. Interaction between projectile, it is nothing but either it is a proton or it may be a neutron, or it is a alpha particle. It is getting my point. So that is the reason the nuclear reaction process, it is nothing but the interaction between the target nucleus, that is uranium 23592, with the projectile. With the projectile maybe that is neutron, no proton, or an alpha particle it is. So getting my point. So this uranium 23592 plus neutron. So this is nothing but these are nothing but in the equation, these are going to be considered as a reactants it is. In the nuclear reaction, the atomic numbers and the mass numbers must balance on both the sides of the equation. If a certain equation it is there, means it will be consist of a LHS as well as the RHS side will be there. So LHS will be reactants will be there, and RHS side products will get. After this reaction we'll get some products that will be there on the RHS side it is there. So reactants, it is nothing but what, now the interaction process where it is going to be taking place between the target nucleus, that is uranium 23592, plus we'll take it as a projectile as a neutron here. Uranium 23592 plus neutron equal to, it will give the products as 2, it is this heavy nucleus, it is depleted into the 2 particles, 2 in equal particles. It is equal particles in the sense that either it is a barium or a krypton, and some amount of the additional neutrons are also going to be releases. Those are going to be called it as a products here. But in that equation, the atomic numbers as well as the mass numbers must balance on both the sides of the equation. On the both the sides in the sense that LHS as well as the RHS side, the atomic numbers as well as the mass numbers must balance each other. Then what is the meaning of this atomic number? Means what? Atomic number, it is nothing but the, see how it's shown here. So this atomic number means, see it, so the Z, it is represents the atomic number here, and this is nothing but number of protons. One example I had considered here, that is uranium 23592 here. So 92 represent what it here, that is the atomic number. So atomic number, it is nothing but only the number of protons here. Then 235, it indicates what, that is mass number. Mass number, it is nothing but it is the sum of protons as well as the neutrons it is. X represents for what, atomic symbol here. So atomic, which heavy element we are using now, uranium, that is represented by symbolically, that is U here. So that is the U, it is going to be represented here. Don't get confused with the mass number as well as the atomic number here. So that is the reason. But whatever the equation will get after this nuclear reaction process, both the atomic numbers as well as the mass numbers must balance on both the sides of the equation. It is getting my point. So next thing it is, the masses of isotopes do not balance on both the sides. So isotope, it is nothing but an atom have a same number of protons. Isotope means what? It is an atom have a same number of protons but a different number of the neutrons. If in the equation, if the isotopes of the atom, it is not going to be balanced, nothing, then what will happen? There is an increase or a decrease in a mass between reactants as well as the products itself. Due to this increasing or a decreasing of the mass, that is also going to be called it as a mass defect. Due to this mass defect, the huge amount of the energy, it is going to be released. Suppose how the energy it is going to be released in the sense that if there is a decrease in total mass, if the mass it is going to be increase or decrease. Suppose if it is energy total mass of the atom, it is going to be decreases, then what will happen? If it is decreases means then there will be a release of energy. If it is going to be if there is an increase in total mass after the reaction process means there is a absorption of energy. That is the reason thus nuclear reaction it is going to be associated with releasing as well as the absorption of energy. Getting my point? So next what it is there, the interaction process between the projectile as well as the target nucleus. Target nucleus it is uranium-235-92. Projectile it is either a neutron, proton or a alpha particle. So which projectile I have considered in this reaction process? Neutron I had taken here. Getting this one? During this interaction process that results into a 3 processes. So which are those processes? So first one it is elastic scattering process, and second one it is inelastic scattering, and third one it is capture or a absorption process. So before discussing these 3 processes, first we need to clear about what is scattering process. Getting my point? Suppose scattering means what? If a neutron it is there, if a neutron it is nothing but a projectile, it is going to be colliding with the target nucleus, that is nothing but uranium-235-92 here. So this nucleus, nothing but uranium-235, when it is going to be colliding with the neutron, but the nucleus it is going to be remains unchanged in isotopic composition, and but the neutron it is going to be undergoes a change in its direction of a motion. Then the process it is going to be called it as a scattering process. Keep it in a mind. Scattering process it is nothing but if a neutron it is colliding, neutron it is projectile and colliding with which nucleus? Target nucleus, that is which one? Uranium-235. If this neutron it is colliding with the nucleus, then this nucleus what it is going to do? This nucleus will be remains unchanged in its isotopic composition. Isotopic composition means it will be having same number of protons but a different number of the neutrons. This composition will be same, but the neutron, whatever the projectile it is there, it undergoes a change in its direction of motion. Then this process is going to be called it as a scattering process. In the scattering process only there are 2 types are there. One it is elastic scattering and one more it is inelastic scattering. So elastic scattering means what? So where the total kinetic energy of the system, total kinetic energy, nothing but the moment after this, nothing but what? The nucleus it is going to be heated with the neutron here. So this neutron it is going to be direction of this neutron when the during the reaction process it is going to be changes. Getting but the moment of that projectile or a neutron, nothing but it is kinetic energy. Moment that is nothing but kinetic energy. Where the in elastic scattering means what? Where the total kinetic energy of the system it is going to be saved. There is neither released nor absorption of the energy. Here in this difference it is where the total kinetic energy of the system it is going to be completely conserved, nothing but saved. There is neither releasing nor absorption of the energy. Getting my point? In second process it is inelastic scattering. Inelastic scattering means what will happen here, in which kinetic energy of an incident particle is not conserved. Getting my point? Here the kinetic energy it is not going to be saved here. Getting my point? Then third process, which one it is? The capture or absorption process. Capturing process it is nothing but during the colliding, during this uranium-235 it is going to be collide or hitted with this projectile, that is neutron itself. If this during this reaction process, if that neutron it is going to be completely disappears from the system, if the neutron disappears from the system, that process it is going to be called it as what? That is capture or absorption process. I hope you all clear with this nuclear reaction process. Okay. So next, let me start with the nuclear fission process. So second bit, what it is there? So nuclear fission process, as already discussed in the previous session, in the previous class also, I have discussed about the fission process. The fission process, it is going to be takes place in a particular apparatus, that is going to be called it as what? Nuclear reactor. Getting my point? So the fission process means what? Basically the fission process here, the heavy element it is nothing but uranium-235-92. It is this heavy element, it is going to be broken into two nearly equal parts it is. During this breaking process, what will happen? Huge amount of the energy it is going to be releases. How this energy it is going to be releases? Due to the mass defect it is. What is the meaning of this mass defect? Mass defect in the sense that certain initially, now whatever the heavy element we are going to use, that is uranium 23592, it will be having a mass number, and this will be having a mass number of 92 it is. Uranium 23592. 235 it indicates what it is? It is the atomic number. Then 92 it indicates what? This atomic number, this uranium 23592 it is there. 23592. Here atomic 235 indicates the mass number, and this 92 it is nothing but the atomic number. So this atomic number it is nothing but what? It is the number of protons, and 235 it is nothing but the mass number. Mass number it is nothing but the sum of protons as well as the neutrons it is. Is it right? So what I told here, so during the fission process, heavy element uranium 23592, it is broken into two nearly equal parts. During this breaking process, huge amount of the energy it is going to be released. How this energy is released? In the sense that due to the mass defect it is. The initial mass before breaking of this heavy element, the initial mass of this uranium will be how much? Mass number will be 235. When it is going to be broken into two equal parts, this mass it is going to be reduces, right? So there is a increasing, or there may be a chances of increasing this mass or decreasing of this mass after the breaking process. So that is the reason what will happen due to this mass defect. The huge amount of the energy it is going to be released, or some amount of the energy it maybe gets absorbed. So fission process. Getting my point? So see here, the nuclear process fission is the process in which large nucleus is uranium 23592. It is splits into two smaller nuclei. It is splitted into two smaller nuclei. After splitting this, that it will releases the some amount of energy it is. Getting my point? So this huge elements means the uranium 235 is there. Some other materials also there. The elements like either it is a thorium, uranium, plutonium are the fissionable materials it is. Getting my point? Out of these three, the uranium it is going to be, out of these three, uranium occurs. So this uranium it is going to be most widely used. This uranium occurs in nature in the form of three isotopes. Which are those three forms? That is, one, it is uranium 234 by 92, and uranium 235 by 92, and uranium 238 by 92. These are the three isotopes of what? Uranium. So of these three isotopes, uranium 235 92 it is going to be most widely used, because of the reason that, so this kind of a material it is going to be it is very highly fissionable. Higher fissionable percentage it is having. Nothing but what? It can be capable of producing or releasing the huge amount of energy after the breaking process. That is the reason the uranium 235 92 it is going to be most widely used out of these three isotopes it is. Getting my point? When an atom of a uranium 235 by 92, it is going to be heated with one neutron, the nuclear process, what will happen? Nuclear disintegration process of the atom takes place. And energy, nuclear disintegration process, it is nothing but splitting into the nearly two equal parts. This uranium 235 92, it is divided into the two equal parts. That dividing of these two equal parts, that is going to be called it as a nuclear disintegration process. And thus nuclear disintegration process results into a releasing of the huge amount of energy in the form of a what? Heat energy. So this heat energy along with additional some 2 to 3 neutrons are also going to be released or ejected. So how we'll write this symbolically? We'll write this equation now here. This we have uranium 235 92. It is bombarding or heated with that is a projectile. Neutron I had taken here. Neutron 1 by 0 it is. Neutron it is having the mass number 1 and the atomic number will be 0 here. So getting my point? So this uranium 235 it is the mass number and 92 it is nothing but the atomic number it is. So after hitting this uranium 235 92, when it is heated with the neutron, it will release this huge amount of energy, as well as the 2 or 3 secondary neutrons are also going to be releases. Getting my point? The releasing energy, it is mainly due to the destruction of matter or nothing but due to the destruction or mass defect. that results into the bombardment or hitting of this neutron with the what it is, heavy element, that is uranium 235-92. Getting my points? That releases the energy. So next, what is the overall? I would like to conclude this one. The nuclear fission process, it is nothing but when an atom of a uranium element, it is going to be splits due to the bombardment. Bombardment, it is nothing but what? It is nothing but hitting process. Hitting process with the, either it is the hitting process by the projectile. Projectile, it is nothing but either a neutron, proton or the alpha particle. So which particle we have taken here? That is neutron. So when this neutron, it is hits with the uranium element and it will produce the huge amount of energy. So that process, it is going to be called it as what? A fission reaction process. Getting my point? This nuclear fission process will takes place in a particular apparatus. That apparatus, it is going to be called it as a nuclear reactor. I hope you clear with this bit. So next we'll move on to nuclear chain reaction process. So we know that uranium 235 nucleus, when it is going to be hit by a neutron, it undergoes a nuclear reaction process. It undergoes a reaction, right? So what it is going to be releases, just see here, uranium 235-92, when it is hit with the neutron, it produces the huge amount of energy. So nothing but this uranium 235-92, it is divided into the two equal parts. Nothing but two equal parts are nothing but the one, it is a barium, and one more, it is the krypton. Along with these things also, some free additional electrons, some additional neutrons are also going to be releases here. So one more point what I told you, the atomic numbers as well as the mass numbers of the equation on both the sides of the equation, nothing but it is a reactant side and this will be the product side it is. And the atomic number as well as the mass numbers of a reactant side as well as the product side must be balanced each other it is. So see here, uranium 235, it is the 235, it is a mass number here. So neutron, it is mass number having the 1 it is. Neutron will be having altogether 235 plus 1, it will be 236 it is. The mass number, how much it is there? This side, reactant side, that is 236, and this side also we should match with the mass number. So mass number here 141 plus 92 plus 3 it is. So how much altogether it will be? Altogether it will also give the 236 itself. Then nothing but what it is, both the reactants as well as the product side, the atomic number as well as the mass numbers are going to be balanced each other. So that is the reason. See here how the nuclear chain reaction process takes place. So here, this is the nucleus heavy element, that is uranium 235-92. When it is heated with the neutron, it releases how many? 3 neutrons. It will produce 3 free neutrons are going to be releases. 1, 2, 3. 3 neutrons are also going to releases. Then what will happen? Each 3 neutrons produces in the reaction strikes. So in this neutron, again it strikes the another uranium 235. So again it will releases what? 3 subsequent what? 3 neutrons are also again it is going to be releases. Again in this one neutron hits with the uranium 235-92 it is. What is the meaning of this one here? Basically uranium 235-92, it is heated with the neutron and it will produces how many neutrons they have produced here? 1, 2, 3. 3 neutrons are released, but these 3 neutrons, again one neutron, again it is going to be one among these one neutron, again it is hitting to the uranium 235 and again it produces the 3 neutrons. So one neutron, it is going to be heated with the uranium 235 and already releases 3 neutrons. Again it is like a chain reaction process. Whatever the 1 neutrons, again it is hitting to the uranium 235 and releases the 3 neutrons it is. It is nothing but what? Each of 3 neutrons produced in the reaction, each of 3 neutrons produced in the reaction strikes the another uranium 235 nucleus and thus causing the 9 subsequent reactions it is. 3 into 3, these are the 3 into 3. 3 3s are what? 9 subsequent reactions are going to be producers. Again these 9 particles, again that results into 3 more neutrons are also produced. So it is going to be continuous like a chain process. 9 into 3, again it is 27. So these 9 reaction in turn further gives rise to 27 reaction. Nothing but what? This nuclear chain reaction process, this process of propagation of this reaction by the multiplication in 3s. 3 3s are 9, 9 3s are 27, 27 3s are 81. So in this manner, the neutrons are going to be released from the nuclear chain reaction process. So again these neutrons are going to be hitting back to the uranium-235, and it will also releases the huge amount of energy along with the 3 free neutrons are going to be producers. So this will be like a chain process. It is the process of propagation reaction by multiplication in trees at each fission. It is going to be referred as a chain reaction process. Getting my point? So next bit, it is nuclear energy. Nuclear energy in the sense that a heavy isotope, that is uranium-235, or we can use a plutonium-239 also, can undergo a nuclear chain reaction by yielding a vast amount of energy. When it undergoes the nuclear chain reaction process, means what? It is in a propagation, in a multiplication, it is going to be occurs in a 3's multiplied. So nothing but 3 3's are 9, 9 3's are 27 reactions. Nothing but during these process, huge or a vast amount of the energy it is going to be produces. So getting my point? The energy releases by this fission of a nuclei, it is going to be called it as what? Nuclear energy or the nuclear fission energy. Getting my point? The fission of uranium-235, or also we can use plutonium-239 also. Plutonium-239 occurs instantaneously and producing incomprehensible quantities of energy in the form of a heat as well as the radiation. What I told here, after this nuclear chain reaction process, huge amount of the energy it is going to be produced in the form of a what? Heat as well as the radiation. Getting my point? Again, if the reaction it is not comes to controlled, if it is uncontrolled, means what will happen? It is accompanied by explosive violence and can be used it in a atomic bombs. It is then it is going to be explode. The chain reaction, if it is not comes to uncontrolled, so then it is going to be used in a atomic bombs. It is because huge amount of the energy it is going to be produces, because the multiplication it is going to be occurs in 3's. The propagation or a multiplication of this chain reaction process occurs in a 3's itself. Nothing but 3 3's are 9. 9 neutrons are going to be produced. 3 neutrons are going to be produced after one chain reaction process. So it is going to be proceeding in the same manner, and it will yields the huge amount of energy. So that energy it is going to be called it as a nuclear energy or the nuclear fission energy. It is. I hope this one it is clear. Next one, it is nuclear fuels. The nuclear fuels means we already clear with these things. In nuclear power plant, the fuel mainly used it is natural uranium, that is uranium-235 also we can use. One more it is enriched uranium it is there. One more it is plutonium it is there. One more it is uranium-233. So these are the different kinds of fuels we are going to be use it, and we will generate the huge amount of energy it is. So next thing it is the natural uranium. It is the parent material for all these things. Enriched plutonium, uranium-232, but the parent and material it is uranium, natural uranium, that is uranium-235. So okay, the materials uranium-235, uranium-233 and plutonium-239 are going to be called it as what? Fissionable materials, because these materials only we are going to be use it in the nuclear fission process. That is the reason these materials are going to be called it as fissionable materials. The only fissionable nuclear fuel occurring in the nature, that is uranium, of which 99.3% of is, that is from the uranium-238 92, and 99.3 means again 0.7% it is from the uranium-235 days. Getting my point? Out of these 3 isotopes, and the uranium isotopes means already discussed in the previous things. Out of the 3 isotopes, only uranium-235 92 it is going to be used, because of the reason that it is having the highest fissionable percentage, and nothing but this material or this fuel can able to produce the huge amount of the energy. So that is the reason used in the chain reaction process also. The other 2 fissionable materials means which are those? Plutonium it is there 239/94 and uranium-233/92 can be produced artificially. So these 2 materials can be produced artificially. From which material? So this one, uranium-238/92 as well as the thorium-232/90. So from these materials, the artificially there are 2 fissionable materials are going to be produced. Which are those? One it is plutonium-239/94 and one more it is uranium-233/92. So these are the different kinds of materials are going to be used in the nuclear power plant. It is there. So whatever artificially, whatever the products we have generated, so those materials are going to be called it as what? Fertile materials. Don't get confused with feasible materials as well as the fertile materials. Fertile materials means artificially we have produced from these feasible materials. Nothing but which are those? Uranium 239 by 94 as well as the uranium 233 by 92. From these feasible materials, artificially we are going to generate some other materials, that is uranium 238 by 92 as well as the uranium 232 by 90. So these materials are going to be called it as a fertile materials. So artificially produced materials from feasible materials. So getting my point? So this is all about nuclear fuels. I hope all of you are clear with today's concepts. Thank you.